In example 6, we're going to be looking at where the function f of x equals x cubed minus 4x is increasing and where it's decreasing. We're going to be using derivatives in order to determine this, so we don't have to guess where the function changes. It's pretty easy to find x-intercepts to find out where the function is positive and where the function is negative, but now we're actually going to be looking at for which values of x is the function increasing and decreasing, which is powerful in the real world when you want to find profit and those kind of things. So I'm going to list out some steps that I use in order to determine increasing or decreasing intervals of a function. The first step I do is I determine dy dx. So if f of x is equal to x cubed minus 4x, then f prime of x is equal to 3x squared minus 4. The second thing I do is I set f prime of x rather, equal to 0 and solve. What this is doing is I'm setting the derivative equal to 0, and this is going to allow me to find the critical points of the graph. So we get 0 is equal to 3x squared minus 4. So you get 3x squared equals 4. X squared is equal to 4/3. So x is equal to plus or minus 2 over radical 3. So those are my two critical points. If I was going to make a sign chart, I would use those critical points. The next thing I do is I'm going to go ahead and I'm going to look at the graph of my derivative. So I'm going to pull up the graph of the derivative right here. You could do this on your calculator. This is not the derivative. This is our original function. But what I want to show you is that if I find the tangent line on this point on this graph, it should be increasing here, should be decreasing here, and should be increasing here. So keep in mind that the slope of the tangent line helps to determine if a function is increasing or decreasing. So right here, now I'm going to actually graph the derivative. So right here is the derivative, and I'm going to go ahead and put this into our notes. Make the graph a little smaller. Okay. So what we want to do then is we want to look at the derivative. So right here, this is 2 over radical 3, and this is negative 2 over radical 3. So what I want you to notice then is on this side over here of x, the derivative is positive. Between negative 2 radical 3 and positive 2 radical 3, the derivative is negative. And then again, from 2 divided by radical 3, the derivative is positive. So step number 4 is then to determine our intervals. F prime of x is positive from negative infinity to negative 2 divided by radical 3, and from 2 divided by radical 3 comma infinity. And f prime of x is decreasing from negative 2 divided by radical 3 to 2 divided by radical 3. What this tells me, which is our final step, is step 5, is to actually determine where f of x, our original function, is increasing and decreasing. So f of x is increasing from negative infinity to negative 2 divided by radical 3, union or and 2 divided by radical 3 comma infinity. It's decreasing between the values of negative 2 radical 3 to 2 divided by radical 3. And this is our answer. This is what the question was asking for. Determine the intervals of increasing and determine the intervals of decreasing. So on your own right now, I want you to try to determine the intervals that f of x is increasing and decreasing for the function x cubed minus 2x. So go ahead, pause the video, take a second, and figure that out. Alright, so now that you have an answer, you should have an interval where f is increasing and where f is decreasing. Let's just do it together and make sure we're all on the same page. So f of x is x cubed minus 2x. So f prime of x is 3x squared minus 2. So what we need to do is set that equal to 0 to get our critical points. So you get 3x squared is equal to 2, and you get x squared is equal to 2/3. So x is equal to plus or minus radical 2 divided by 3. Now what we need to do is graph 3x squared minus 2. If you don't know what this looks like, again, we're graphing this right here. If you do not know what this looks like, go ahead and just graph it on your graphing calculator, or you can make a rough sketch. Either one will work. So I know that negative radical 2 divided by 3 is somewhere over here, and I know positive radical 2 over 3 is somewhere about right here. So I'm going to go ahead, those are my critical points. And I know this is a parabola facing upwards, so I know it's going to look something along these lines. It's okay if your vertex is not perfect. And so from negative 2 radical 3 this way, so from negative infinity to negative 2 radical 2 divided by 3, and from radical 2 divided by 3 to infinity, the derivative is positive. And then in between negative radical 2 over 3 and radical 2 over 3, we get a negative. This tells me that the derivative is negative on those interval and it's positive on the intervals that are shown. So our answer is quick. F is increasing on the intervals negative infinity to negative radical 2 over 3 and radical 2 over 3 comma infinity. Sorry, these should be brackets. It's important that we note that when we talk about f, we use brackets, and when we talk about the derivative, we use a parenthesis. This is because increasing and decreasing will contain those critical points, while the derivative would be differentiable on the open interval, very similar to when we use the mean value theorem. And so f is decreasing on the interval negative radical 2 over 3 to radical 2 over 3. And that's it. That's all there is to it to determine increasing and decreasing components of a function.